Hey guys, my name is Austin Farrar. Today we got another calculus problem on the board here. And today we're going to be doing our problem. It's another replacement value problem, initial value problem, excuse me. Where we start with this given function. So if x dy dx is equal to the square root of x squared minus 4. Now we have this condition here given to us in the problem where x is greater than or equal to 2. And the reason for that is if you plug any number that's less than 2 in here, you'll have a negative number inside the integral, inside the square root sign, and that could be a problem because we have imaginary numbers. We don't want imaginary numbers in this video. Okay? Cool, so that's why that condition is here. And this is our initial value that's given to us in the problem. We'll get to that later. So right now, the first thing I did is I said, alright, I'm going to take the x to the side and the dx to this side. So I'm going to divide the thing by x, multiply this by dx, and I get this. dy is equal to the square root of x squared over minus 4 over x dx. Again, all I did is take this x to this side and take this dx to this side. Okay? Fantastic. Alright, so now I want to direct attention to this box right here. Now this is my box of equations. And these are kind of just general things I'm going to be using throughout this equation. And I'll explain what I'm going to use and why I'm using it. But I just want you guys to know this is the general box of equations that you should probably memorize for this function here. Okay? Alright. So, first of all, we're using our first box equation, x equals a secant theta. It should be in your calculus textbook. It's just something you have to memorize and get used to. So don't forget about that. So if x equals a secant of theta. Now, a in our case, the variable a in our case, is equal to 2 squared we have up here. So imagine this says, again, reading the top problem again with a replacement in it, of x dy dx is equal to the square root of x squared minus 2 squared. 2 being a. Okay? So I plug 2 in for a right here, and so I get x is equal to 2 secant of theta. Alright, got that part down. Now, all I'm doing for this next part is I'm taking what I have here for my x, and I'm substituting it in here for my x here. You'll see why in a minute, but I'm substituting this in for my x here. So I have 2 secant of theta squared minus 4. Simplify this, right? So I square this, and I get 4 secant theta squared minus 4. Now what I did right here in this step is I took a 4 out. So it's easier to see what you can change this to. Now, if you don't remember, one of the fundamental theorems is sine squared plus cosine squared is equal to 1. So again, that's sine squared theta plus cosine squared theta is equal to 1. And that's how I got, and if you divide by, I believe it's cosine, then you'll get secant squared theta minus 1 is equal to tangent squared theta. Okay? And that's where this substitution comes in. So again, I substituted secant squared theta minus 1 with tan squared theta. Alright, so now we have this portion. So now, here's what we're going to do with this. Basically, we have this part of the integrand. So this, not the integrand. This part of the inside of the square root function is equal to this. So what I'm going to do is I'm going to take that and I'm going to put it in for this. So I have 4 tan squared theta, and then I have my x value I have right here, which is right here. So I take my 2 secant of theta and put it right there. And then multiply by my dx. Now again, my dy dx is right over here. So all I had to do here is I took my derivative of my function. Okay? Of this function, you get this. Again, this is one of those you have to memorize. It's not something that comes too easily. So you gotta make sure you memorize this one. Okay. So that comes in over here. And the rest of the problem is pretty straightforward after that. So again, you're trying to find the initial function itself. So y equals this without the plus c. Okay. So what I did here is I plugged this in. Like I said, plug this in for dx, substituted this in for x squared minus 4, substituted this in for x. Okay? Once I did that, you simplify this. So the secant theta is here, cross out, the 2's cross out here, and you're left in the, again, the square root. You can simplify the integrand first. So what's left up here, you end up with a 2 tan theta. Okay, and what I did is I took the 2 out on this side, and so multiply that tan theta that was left over up here times this tan theta to end up with tan squared theta, d theta. Okay? Don't forget that d theta, by the way, come in handy, because you're taking the integral for respective theta, so you have to have that d theta in here. Cool. Alright, so again, it simplifies here. Again, using that same identity I talked about right here, you can change this to 2 times the integral of secant squared theta minus 1 d theta. Cool. Alright. Now we got that down. Now time to solve this problem. So we have y is equal to 2 tan theta minus theta. again, what I did here is I just substituted in my values, and I ended with tan theta minus theta from here to here. Okay? So after doing that, then I said, okay, I'm going to plug in my tan theta. Again, I'm plug in what I have for tan theta, what my theta is, right here. Again, my theta, just seeking inverse of x over a. Again, our a is 2 right here. I plug that in, get this, multiply my 2 out to make sure it's a more simple, in a more simple format, and end up with, and you end up getting rid of the 2 here, and having the 2 in front of this. And then what you do after that, I didn't show it here because it's running out of space, but what you have to do is you plug in your initial values. Once you simplify this, you plug in your initial values, and you'll end up getting c is equal to 0. Okay? Once you plug that in, you'll end up getting c is equal to 0. And so you know that there's no value, no plus c over here. So your final answer is just this right over here. Okay? Which is y is equal to the square root of x squared minus 4 minus 2 inverse of secant x over 2. Okay? Alright guys, thank you very much for watching. I appreciate it. If you have any questions, comments, or concerns, make sure to check out, leave a link or something in the comment section below. Thank you so much for watching. Have a great day and have fun with calculus.